Remember that in the last chapter, we solved linear equations such as 3x plus 5 equals 9. We would solve this linear equation. It only had one variable. And when I found out what x was, I could subtract 5 from both sides, and I find out that 3x is equal to 4. So x has to be equal to 4/3. So what I did was find out that 4/3 is the one solution that when I plug it in for x makes the left-hand side equal to the right. One variable, one answer, so that was my solution. Well, now let's suppose I had the equation x plus y is equal to 6. And I wanted to think to myself, well, what two numbers do I have to add together to get 6? Let's say I chose the numbers 3 plus 3. Well, 3 plus 3 equals 6, right? Therefore, the solution to this equation is the ordered pair 3, 3. Because I can plug in 3 for x, 3 for y, and the left-hand side equals the right. Let's say I wanted to try the numbers 12 plus negative 6. Now, does that equal does 12 plus negative 6 equal 6? Yes, it does. So therefore, the ordered pair 12, negative 6, when I plug it in for x and y, causes the left to be equal to the right. And I don't know, let's try one more. Let's say I wanted to find out, or I wanted to add, 0 plus 6 equals 6. Well, that's true also. So the ordered pair 0, 6, I can plug in for x and y and find out that that equals 6. What this all means is that there are an infinite number of solutions that cause my linear equation to be true. The trick is finding which of those infinite solutions, or which of those solutions cause this to be true. So let's look at this equation, this linear equation, 3x plus 2y is equal to negative 15. And let's ask ourselves, well, does the ordered pair negative 3, 3, when I plug it into this equation, does that cause the left-hand side to be equal to the right? In other words, is the point negative 3, 3 a solution to this equation? Well, I don't know. Let's try it out and see. We're going to start with our original equation of 3x plus 2y is equal to negative 15. And now I'm going to plug in my value for x, which is a negative 3, my value for y, which is a positive 3, and I'm going to solve this, or simplify it. 3 times negative 3 is negative 9, plus 6 is equal to negative 15, but negative 9 plus 6 is equal to negative 3, and negative 3 does not equal negative 15. So therefore, this ordered pair of negative 3, 3 does not satisfy the solution and is not, it does not satisfy the equation, and it's not a solution. Not a solution. Okay. Well, let's try this one. Here we're asked to find out whether the ordered pair negative 1, negative 6 is a solution to this linear equation. So if I have 3 times some number plus 2 times another number, is that equal to negative 15? So we're going to take negative 1 for x and negative 6 for y, and we're going to see if that works. So I get negative 3 minus 12 is equal to negative 15. Change, and yes, negative 15 is equal to negative 15. So what that says is that the ordered pair negative 1, negative 6 is a solution It is a solution to my equation 3x plus 2y is equal to negative 15. And we could keep going on, trying out all sorts of ordered pairs on the graph, on our Cartesian, our coordinate plane, to find out which ones satisfy. Because as we saw up here, we can have more than one be a solution.